So, hello everyone. My name is Kevin Ventimia, and I am the data model lead for Team CPMC in this Team CPMC. In this video, I will be going over the code pertaining to the storage system we have in our project. To start things off, we have decided to set the limit of the size of the file and the size of the file requested by the user to be less than 128 kilobytes. This is because we don't want to have a scenario where we handle a file that is way too large for our API. This also eliminates potential crashes or failures within the API itself. As you can see in this first line, it just sets the max file size to be 128 kilobytes or less. And then the next line shows the max request size to be 128 kilobytes. So in the storage properties class, we define the storage location. And as you can see, it's just upload dash directory. You can also see that there's this annotation called configuration properties, with the prefix storage inside. Basically, this is just binding all the properties that start with the storage prefix to the corresponding class. In order to enable this annotation, we have to go inside of our main application class and add this line, the @enable configuration properties, and then we'd have the class or the class location. Next, we have to create the storage service interface. This interface will allow the file upload controller to connect with the storage layer, which in our case is a file system. This interface will define the abstract methods to allow us to initialize, store, remove, or retrieve files from the file system. And then this interface will also be implemented in our file system storage service class. As you can see, in this interface, it has the abstract methods init, store, load all, load as resource, and delete all. I will go into depth about what each of these means in this next class. So as you can see, the class file system storage service is annotated using the service annotation. Basically, just lets Spring know that this class is a service. It implements the storage service interface. It has this constructor, which will be used inside of the controller to initialize the storage property or the storage system service, so the controller can use all of the methods below. So the first method we have is called store, and it takes a multi-part file as its parameter. This method checks to see if a file is empty, and if so, it throws an exception. Then it creates a path variable that will be used to store the file and locate it in the future. Then it checks to make sure it is storing the file in the correct one or the correct directory. Next, checks to see the method checks to see if the file exists, and if it does, replace it, which is seen in this block of code right here. And then finally, if something goes wrong, it'll throw the custom storage exception. This storage exception extends runtime, and it's an exception that has two constructors, one with just a message, and then one with the message and a throwable cause. So as you can see here, for example, this catch block will catch the IO exception, and it will have a message, and then it'll have the cause here. This storage exception is thrown when the file is empty or the directory could not be found. So that's why it's thrown here where the file is empty, where it checks to see if the file is empty, or here where it checks to see if the file is in the right directory. The next method is called load all, and it returns a stream of type path. This method will simply load all the files in the file system. If something goes wrong, it'll throw the storage exception as mentioned above. The next method is called load. And its parameter has a parameter called string file name that returns a path. This method will pretty much just load the file from the system, but it also allows you to create a path from using a file name. And you'll see this used in this next method. So this next method is called load as resource, where it has a string file name parameter and it returns a resource. This method will create a path variable using the load method and the file name parameter. It will then turn the path variable to a resource by using the URL resource constructor, which will create a URL resource. It will check if the resource exists or if the resource is readable. If either of those conditions are true, it'll return the resource, and if it's not, it'll throw the storage not found file exception, or a storage file not found exception, which basically just applies the same concept of the storage exception we made, but instead of extending the runtime exception, it extends the storage exception. This file or this exception is also thrown when the file requested it does not exist inside the file system, which is what differentiates it from the previous storage exception. And finally, as you can see, this constructor, when you use this constructor, it requires you to catch the malformed URL exception, which is why we have it here. And it'll also just throw the storage file not found exception, because if it can't find the file inside the system or it doesn't exist, this is the exception that's mapped to it. And then we have the delete all method, fairly easy method. It just deletes all of the files in the all the files inside of the file system. And then finally, we have the method called init that initializes the file system, and if something goes wrong, it throws the storage system because it cannot initialize the storage or find the directory. So yeah, this is basically what's going on inside of our code, at least for the file system. I can show you a little bit kind of what's going on inside the application class. So we have this method, which is called init. Basically, it's going to call the method storage service.deleteAll. So every time the server is launched, it'll delete all the files stored, and then it'll initialize the storage service. So if we run it, I can show you how this works. So the server is up and running. So let's go to localhost 8080, and as you can see, here's the front end part where the user can choose a file. I will show you example of a working file and one that does not work, meaning it exceeds the limit of 128 kilobytes. So I'm just going to choose this random file, right? And so as you can see, it's here, it's loaded. And so now if I click upload, you can see how the file system knows that it's stored here, right? So I can close this, load it back up, and you can see the file system is still here. Now if I stop the program or a server and I run it again, you can see how the file is no longer here, and that is because, once again, we delete all of the files stored upon the server being loaded. So let's show you an example of how a file is checked if it is over 128 kilobytes. So as you can see, this was about 205 kilobytes, which exceeds our limit of 128 kilobytes, and this is the error we get because of the file exceeding the limit. One idea that we have to come up with is to figure out a better user interface or user-friendly page so the user doesn't see this, because this can be very intimidating for a user that doesn't know what's going on. So yes, we'll have to come up with something better. But other than that, that is pretty much the storage side or the file system side of our program. I hope you enjoyed it, and I look forward to talking with y'all soon. Thank you.